Hello students, good afternoon everyone. Well, I had told you that my lesson electrolysis will be done in two parts, part 1 and part 2. Last week I had uploaded the part 1 of the video of the lesson electrolysis. It's a very big lesson in ICSE board and a very important lesson because this is the base for the lesson of electrochemistry in standard 11th and 12th. So today I continue with the second part of my lesson electrolysis. So keep your book, ICSE book in front of you because you will see the equations. I won't write all the equations, it's a very big lesson. I will just tell you the last minute points which you should keep in mind while doing the lesson. And chemistry is always done with the help of a notepad and pencil. Always keep something in your hand. So now, last time I had used two colored pens, if you remember. I had used two pens for differentiating between the cathode and anode, if you remember, right? I had used. Now today I am again keeping two pens in my hand, the pink pen and the blue pen. The pink pen and the blue pen. Now these two pens, I will tell you the use of the two pens later on, because you can also learn the lesson for your exam in this way, how to keep the points in your mind, how to keep the points in your mind. Now for this I will also tell you the basic things which you should keep in your mind while doing this lesson. That is the later part of the lesson will come. If I take this as the beaker, if I want to conduct an electrolytic decomposition reaction, which I will tell you how we will do, anode and cathode. So please remember the pink pen here, the pink pen will be the anode. The part of anode means what? Oxidation or reduction, recollect what I have told. At cathode what is done and at anode what is done. Obviously at anode oxidation and at cathode reduction. Your last part, what are the two electrodes, what are the cations, what are the anions, the electrolytic dissociation of sodium chloride, molten sodium chloride, okay, and not solid, versus to that of hydrochloric acid. HCl. I had told all this, and a comparison of metal conductor copper to that of copper sulfate as an electrolyte. This I had told. So this jar which you see is the beaker, and this solutions which you see here are the electrolytes which will be taking part in the reaction. The pink one will be anode, and this blue one will be the cathode. Right? And for this I don't have so much. This electrical circuit will be made like this, which you have to draw to show how the bulb will glow accordingly. That is not required now. Just remember the whole lesson in terms of these two pens, and because it is all the reactions which is taking place at the cathode and anode, which is the most important part of the lesson. And the key words are gain of electrons, loss of electrons, oxidation, reduction. Okay, so now we start the second part of the lesson. In the second part of the lesson, I have written some points here. The first part of the lesson will be the electrolysis of an acid, electrolysis of a base, and electrolysis of a salt. So keep it under your heading for an acid, for a base, and for a salt. Now what will you do here? You can write here that acids, when dissolved in water, dissociate into free mobile ions, okay, and accordingly they are classified as strong electrolyte or a weak electrolyte, and this comparison I told you in the last session. Strong electrolytes are compounds which are completely dissociated and are very good conductors of electricity, right, and they are strong electrolytes. Weak electrolytes are those which dissociate partly and are poor conductors of electricity. So for example, for you, if they ask you in your exam, give the dissociation reaction of acids to base to salt. First question, dissociation reaction of acids, base and salt. And also if you remember, you should also keep in mind the difference between the word dissociation and ionization. Ionization is the process which takes place in polar covalent solvents. Dissociation is the process which takes place in electrovalent compounds. Then in ionization, it is the process of formation of charged ions from the molecules of polar covalent compound like HCl. Charged ions are formed, like HCl will break up into H plus and Cl minus. HCl is covalent. And what about dissociation? In dissociation, in the process of dissociation, the separation of ions which are already present, the ions are separated which are already present in the ionic compound, like lead bromide, which you will see here. It separates, it's an ionic compound, it's a salt, it separates into lead, Pb2 plus and 2Br minus. So this is another important question which is frequently asked in exam. Give the difference between ionization to that of dissociation. So I was talking about acid, base and salt. So in acids, these acids dissociate into hydronium ions, H plus Cl minus. H plus is nothing but hydronium ions, this I had told you. Okay, like and in acid will again come strong acids, weak acids, strong electrolyte, weak electrolyte. I have written one example of a strong electrolyte, sulfuric acid, H2SO4. It breaks into 2H, it breaks into 2H plus and sulfate, SO4 minus. That is for sulfuric acid. Now, what about base? A weak base, if it's a strong base, an example for strong base will be potassium hydroxide, K plus OH minus. So like that you can give for weak base calcium hydroxide, Ca2 plus 2OH minus. You have to keep on writing two examples. Magnesium hydroxide Mg2 plus OH minus. So strong acid mein H2SO4 is 1, HCl is 1, and a weak acid you can write for acetic acid. CH3COOH will break up into CH3CO minus plus H plus. Okay, anion and cation. These are the acid and base. What about the salt? Salts are acting as strong electrolytes because they give positive and negative ions in the solution. I have written the example of lead bromide and silver nitrate. So these both break up into this cations and anions. So this is a quick thing of the second part of your video, my first video, and I am on page number 109, ICSE chemistry. Right. Now please turn the book, turn the page. Now another important thing, and the word I have written here is, which is very important in this part of the lesson, is selective discharge of ions. Selective discharge of ions. Like we had talked in osmosis, selective permeability, osmosis, selective permeability. Like that is selective discharge of ions. Now what is the selective discharge of ions? How will you define it? The preferential discharge of ions present in an electrolyte at the respective electrode is also known as selective discharge of ions. If the solution contains more than 2 cations or anions, the selective discharge of ions depends upon 3 important factors. If there are more than 2 or 3, then their discharge depends upon the important factors. Now what are the important factors? The position of the ions in the electrochemical series. The position of the ions in the electrochemical series. Second, what is the concentration of the ions in the electrolyte? And third is the nature of the electrode. So the factors which affect the selective discharge of ions are, first is the discharge of cations and anions at the respective electrode. So this you will understand better if you will first understand what is a electrochemical series. What is a electrochemical series? So I have till now given you 3 questions. Compare the dissociation of an acid to the base to that of a salt. Strong electrolyte, weak electrolyte for acids. Strong base, weak base. In that you will take potassium hydroxide, weak base ammonium hydroxide. Strong may you will take HCl, weak may you will take acetic acid. And salt, lead bromide and silver nitrate. That. After that I have told you, give the difference between ionization and dissociation. Third question was, what is selective discharge of ions and on what factors it depends upon? Yes. Fourth question comes for your LMR is, last minute revision, what is the electrochemical series? Now, this electrochemical series is different for a cation and it is different for an anion, because this whole lesson rotates on cation and anion. Cation and anion, cathode and anode. So, what is the electrochemical series? Depending upon the ease with which the metal loses its electron and forms the ions, and when they are arranged in a series, like the in the lesson metal and non-metal extraction of metals depends upon the position of the metal in the reactivity series. If you have read displacement reaction, a more reactive metal displaces the less reactive metal from the salt. A less reactive metal cannot displace a more reactive metal from the salt. For example, copper sulfate and iron. Copper sulfate and iron. Iron, if you can just recollect, for reactivity series of metals, displacement reaction. There are many kinds of reactions. I am just giving you a reference. This is electrochemical series for cations and anions in parallel with reactivity series of metals for extraction. See, iron is more reactive than copper because it is placed above hydrogen. This is a rule of the electrochemical series or any reactivity series. The elements above hydrogen are more reactive and the reactivity decreases as we go down the group. The reactivity decreases. The most reactive metal here is potassium. That is why it is stored very properly. Then comes sodium, how it is stored if you recollect. Then in the least reactive is one will be placed in the lower series. That is here it is the mercury and silver. They are the least reactive metals because they are almost, you can say, they will not react that strongly. They will react, they will go, but not that strongly. These are very reactive metals. So the electrochemical series is this, what I told you. And what do these metals form? The metals form cations. The metals loses its electron more easily to form positive ions called cations. And now these cations are formed at the cathode. They are formed at the cathode. And these cathode, like potassium. Potassium will lose its electron and reduction reaction takes place at cathode, if you recollect your previous one. And then what happens? The tendency with which these positive ions are discharged at the cathode by the gain of electron to form a reduced one, it increases on the descending electrochemical series. That is metal forming a cation. Cation is going to the cathode. At the cathode they gain the electrons to form a neutral atom, and this is going down the series. All of them, you will see them, some of them when you will see the electrolysis. So the tendency of the cations to get reduced at the cathode increases on descending electrochemical series. Descending means down the series. And that is lower the position of the ions, forming the element in the electrochemical series, greater will be the tendency of it to be liberated at the respective electrode. This is the rule. Keep it by heart. This is the key point of the electrochemical series. I repeat again, the discharge of cations and anions, that is lower the position of the ion forming the element in the electrochemical series, greater will be the tendency of it to be liberated at the respective electrode. This was for cations. And what about anions? The comparison for anions, if they ask you to give, what you will write? Sulfate, nitrate, chloride, bromide, iodide, hydroxide. These negative ions called anions, the negative ions are called anions, they are discharged at anode by the loss of electron, and the tendency of the anions to get oxidized at the anode increases on descending electrochemical series. So if they give you the comparison, they will ask you the comparison of what is the electrochemical series. Give the electrochemical series of a cation, could have an anion, and where are they formed. Got it? So second factor on which selective discharge of ions depends upon. Third, another factor on which just now told you on what it depends upon is the concentration of the ions in the electrolyte. Higher is the concentration of the ion in the electrolyte, greater is the probability of its being discharged at the respective electrode. For example, if we go for molten sodium chloride, NaCl, NaCl salt, it decomposes into Na plus Cl minus. Now what happens at the cathode? Hydrogen is discharged. At anode, hydroxide are discharged. Now at cathode you will see hydrogen gas is liberated, and at anode O2 is evolved, which you will see in electrolysis of sodium chloride. Like that, you have to keep some examples in your mind. Now the third factor on which selective discharge of ions depends upon is the nature of electrode. Underline the word inert and active. Inert electrode and active electrode. Inert electrode means like iron, graphite, platinum. Iron, graphite, platinum. Inert means they don't take part in the electrolytic reaction. They don't take part in the electrolytic reaction. Active electrode is one like copper, silver, nickel, and they part in the electrolytic reaction. Also, if the electrodes are in active state, and that is the active means like copper, nickel, silver, the anions migrate at the anode but are not discharged. And instead, if the active electrodes are used here, they lose electron and form ions at the anode. Okay, so active electrode and inert electrode. So these are the things on which the selective discharge of ions depends upon. So this was the background. Now we will come to the one example of electrolysis of in your book. If you see your ICSE book, they have given you the electrolysis of lead bromide on page 112. You have to make a summary chart. Then electrolysis of water they have given using platinum electrode. Electrolysis of acidified water using platinum electrode. Then electrolysis of copper sulfate using copper electrode. Electrolysis of copper sulfate using copper electrodes. Electrolysis, 4 examples are given. I will explain you electrolysis of lead bromide. But for your comparison and for your study, you should make a flow chart of all the 4 types of electrolysis and a summary chart which is given in your book, and by heart it for your example. One common diagram can be more than enough to explain the diagrammatic representation of that particular electrolytic cell. Okay. Now we proceed further. Now we will go for electrolysis of molten lead bromide. Now for this you have to draw the diagram, very important diagram. The diagram will be, I am just drawing a simple one. Every diagram in your board exam should be drawn in a box. First thing, a diagram should be in a box. Then you should label the diagram only on one side of it. Okay? Only on. I'm just drawing a prototype of it. I'm not going into detail of it. Okay? Okay, this is the graphite anode. The another one is the iron or graphite. Cathode. Okay, and then as usual the electrolytic cell. The key is there and the bulb is there, and then this connection is there. Okay, anode and cathode. Okay, so electrolysis of molten lead bromide. This is molten. This dotted one is molten lead. Now what you will write here, you will give the heading electrolysis of molten lead bromide. Now the things which you will write here, first you will write the electrolytic cell. The electrolytic cell is made up of silica and the crucible is heated slowly from outside, slowly and gradually, not at high heat. Okay. Second, it cannot withstand high heat because then the reaction will not go properly. Second, the solid lead bromide is a non-conductor of electricity because it is a salt, strong electrostatic force of attraction. No ions are there, so no solid lead bromide is a non-conductor of electricity. Third point is the ions become free when the lead bromide is in the molten state. So you will underline the word molten state. So hence the crucible is heated to maintain lead bromide in the molten state. So this is the first point here, molten state. Then comes the sequence of reactions which will take place here. So the dissociation of lead bromide will be, lead bromide will dissociate into PbBr2 will dissociate into Pb2 plus 2Br minus. You should underline every reaction and write it everything in step. Pb2 plus 2Br minus. First, after this you should write the metallic lead is discharged at the cathode as lead metal and the bromine is liberated as brown bromine vapors at the anode. Okay, the cathode, as you know, is the electron donor. It donates electron there, and the metallic lead needs the electrons to discharge at the cathode as neutral lead atoms or metallic lead. If you want to write the description of it, at cathode, what will happen? Pb2 plus 2 electron will form Pb. So now after this, you should write reactions at cathode, reactions at anode. So reactions at cathode will be Pb2 plus plus 2 electrons. It will get transformed into neutral lead metal. Okay, this one at cathode. The Pb2 ions are discharged at the cathode and as neutral lead atoms by accepting the electrons, and this lead metal comes as a grey deposit. It comes as a grey deposit, grey color. Okay, at cathode. Now what happens at the anode? The bromine will now the bromine ions are discharged at the anode. The bromine vapors are formed there and they are reddish brown in color. Br minus 1 electron will, this is happening at the anode. Matlab oxidation here, reduction here, remember. Okay, and it becomes bromine. 2 bromine will combine to form vapors, bromine vapor. Okay. That is, the bromine ions are discharged at the anode as neutral bromine atoms by giving up electrons. The bromine atoms combine to form bromine. Okay, now so electrolysis of molten lead bromide involves oxidation reduction reaction, and hence a very important term, it is a redox reaction. So the features of this electrolytic cell will be the diagram, proper diagram. Then molten lead bromide is used, silica gel is the crucible used, and the electrolyte is molten lead bromide. The electrodes are cathode, are iron or graphite. The anode is graphite. The temperature is 380 degrees centigrade, and the electronic means the dissociation of electrons shown you here, and reaction at cathode and reaction at anode. So this is about electrolysis of molten lead bromide. Like this, in your book, it is your electrolysis of acidified water is given, electrolysis of copper sulfate is given, Very easy. Copper sulfate is another important salt. The electrolyte used here is aqueous copper sulfate with dilute sulfuric acid, because the sulfuric acid acts as a catalyst. It enhances the rate of reaction, and acidification of electrolyte with the dilute sulfuric acid enhances the conductivity of the electrode and may prevent it may prevent the hydrolysis of the electrolyte. This is another hot question asked here, and usually in board exam they ask you electrolysis of copper sulfate more than lead bromide. This was a simple one I told you. For copper sulfate, what you should keep in mind, electrolytic cell, same diagram will be there, but copper cathode and copper anode. Okay, cathode, and you should always give the representation of these charges, negative and negative here and positive here. Anode is positive, cathode is negative. So keep it like that. So if you just make the mental mapping of copper sulfate, the dissociation of copper sulfate diagram will be this common diagram. Cathode will be also copper, anode will also be copper. And what will be the electrolyte? Copper sulfate with little sulfuric acid. Then electrodes are, cathode is copper, anode is also copper. They both are active electrodes. You have to keep this in mind. They will take part in the reaction. Okay, then the temperature is ordinary temperature. The amount of current is 3 amperes. Now then you will write the dissociation reaction of copper sulfate. That is CuSO4 will dissociate into Cu2 plus sulfate SO4 minus. Okay, and of aqueous copper sulfate. So H2O will also dissociate into H plus OH minus. Now, what reactions will take place at the cathode? At cathode means at the negative end. What reactions will take place? Copper will accept electrons and will get deposited as copper metal Cu2 plus 2 electrons Cu. Okay, and copper ions are discharged at the cathode, and neutral copper atoms, they are formed by accepting the electrons. Okay, that's you will write here. So the product formed at cathode is the copper metal. What reactions takes place at anode? Copper minus 2 electron forms Cu2 plus. Sulfate and hydroxide will migrate, but they will not be discharged. Why? As per the that series which you had seen where they lie, so they will not be discharged. Only the product formed at anode will be nil. Only copper ions will be formed there. So the process of oxidation and reduction is also taking place here. The process of oxidation takes place at the anode, and hence it is called the oxidizing electrode, which I had told you, and cathode also told you. So you have to compare one salt to the other salt, lead bromide to copper sulfate. Now to brief up more, I will now come to the another significant part of the lesson, that is the applications of electrolysis. Now we come to applications of electrolysis. Now broadly there are 3 applications of electrolysis. First is electroplating of metals. Second is electro-refining. And third is electrometallurgy, extraction of metals. Now, you should make a table for the comparison of all of the 3. Matlab, electroplating the procedure, electro-refining the procedure, electrometallurgy as per the reactivity series of the metal, the procedure. Now first we come to electroplating of metals. Now this electroplating of metal is a very important application in our industries, because it is highly in demand and it is done, and people are doing it as after they are acquiring their knowledge. So for this, how will we go for it? How will we read this LMR for the electrochemical, which one? For the electroplating. First you will define what is electroplating, right? Now what is electroplating? In this electroplating, what is happening here? Electroplating is an electrolytic process of deposition of a superior metal like nickel, silver, chromium, gold. This is a superior metal, nickel, silver, chromium, gold, over a base metal. So the keywords are superior and base, over the surface of a base metal or an article like copper, iron or brass. So the thing here is one type of metal has to be acted as an anode and another will be the cathode. So the thing which has to be electroplated will be the cathode, negative terminal, and from which it is electroplated, that will be the anode. That first thing you keep in mind. So electroplating is required to prevent corrosion, that is rusting. Iron is plated with nickel or chromium. They are also used for decoration purposes because it gives an attractive appearance. Like brass metal is plated with silver or gold. Now, so this was what is electroplating. Now, what are the conditions required for electroplating? Next question. So far, I have given the number of questions should be more in your list. Starting with acid, base, salt as an electrolyte. Then starting with what is an electrochemical series of a metal to that of cation to that of an anion. Then show it in a diagrammatically what significance it has in selective discharge of ions, on what factors the selective discharge of ions depend upon. This was the previous one. Then came the decomposition of lead bromide to that of copper sulfate with the diagram, with the dissociation reaction with cathode, anode and overall. Also the difference between ionization and dissociation. Okay, this was your previous questions, 7-8 questions. So now, what are the conditions which is required to maintain electroplating? First point you should write is the article to be electroplated is always made the cathode, as I told you now. Since the metal is deposited at the cathode, the metal to be plated on the article is always made at the anode. So you have to underline these key lines of your exam during your exam. Since the metal at anode continuously dissolves into the solution and it has to be replaced periodically, so that is why it is to be made the anode, the positive terminal, and the cathode, the negative one, which is to be electroplated. Then the electrolytic solution must contain similar metal ions like silver, nickel, on which these ions travel towards the cathode and get deposited on the metal easily. Another important factor here is uniform temperature. If high current is there, then uneven deposition of metals will be there. Therefore, uniform temperature and also only direct current should be given because alternating current causes discharge or ionization, due to which no effective coating is found at the cathode. So these are the questions if they will ask you what is electroplating, under what conditions it should be done, what metals are electroplated, which metals act as cathode, which metals act as anode. Okay, now we come to electroplating with silver. The diagram will be another simple diagram. I rub this. Application, electroplating with silver. With silver. Now here what diagram will you draw? Again you will keep one box diagram, green box. Take a beaker. Again 2 electrodes, anode and cathode. Anode, cathode. Now here electroplating with silver we are doing, right? So here we take block of silver. This anode is nothing but a block of silver. Now what about the anode? This anode is nothing but the article to be electroplated. Say I want to electroplate a spoon. So I will draw one spoon. I want to electroplate one spoon. So I will draw one spoon. Okay. The article to be electroplated, you will write. The article to be electroplated. To be electroplated. Okay. And then anode is positive. As usual, keep this battery, this, and then that ammeter, and then this. Okay. So what features will you write here? What will you write here for this electrolysis of electroplating with silver? What will be your first point here? In order to get perfect deposit of silver on a brass spoon, the spoon is first cleaned, washed with caustic soda and then hydrochloric acid. Why this is done? To remove the impurity found on it. After that, the spoon is wiped, it is dried, and then it is made as the cathode. So now, as I told you, these two pens electroplating with silver. So this pink one is anode, and this pink one is anode, and the spoon one is this. So this pink has to be electroplated, silver has to come on this cathode. So pink pen is anode and blue pen is cathode. Now the electrolyte. What is the electrolyte here? Aqueous solution of sodium chloride, or sodium chloride means sodium cyanide. Cyanide is the electrolyte. It is prepared by adding sodium cyanide to a solution of silver nitrate till the precipitate is formed. So that is the electrolyte over here is sodium argentocyanide. That is the electrolyte here. Sodium argentocyanide. NaAgCN2. NaAgCN2. AgCN2 will be in bracket. Okay. Now, what is the cathode here? Clean, as I told you, the brass spoon. What is the anode here? The anode is the active electrode plate or a block of silver metal, right? Now, what are the electrode reactions which takes place here? The electronic reaction which takes place here is the NaAgCN2, which is the compound being used here, breaks into three components: silver, Ag plus, Na plus, 2Cn minus. So the electrolyte used here is Na. The electrolyte used here is, 1 minute, just a minute. The electrolyte used here is NaAgCN2. NaAgCN2. Okay, it dissociates into Na 2Ag plus 2Cn minus. It dissociates into this, right? So now the dissociation of aqueous silver cyanide, and also of water you have to show. Water, it dissociates into H plus OH minus. Okay, and that about NaCN. NaCN is also formed here. NaCN, Na plus Cn minus. Now, okay. Now the reactions which takes place at the cathode are Ag plus silver. In Ag coming from the electrolyte. Ag coming from the electrolyte will go and form silver metal. It will form here at the cathode. So Ag plus electron at cathode forms plain silver, Ag. In presence of other ions like sodium, which is found here, hydrogen, which is found here, and Ag ions, they move towards the cathode and are discharged as Ag atom by gaining electrons and deposit on the spoon as a firm coating. The thickness of the coating will depend on the duration of the current passed. Okay, so Ag plus electron forms silver at coating on the cathode. What happens now at the anode? The atoms at the silver anode loses electron to form Ag ions and enter into the solution. Ag plus electron is here. Ag plus electrons forms here at the cathode. Now what happens at the anode? Ag minus electron, it is going away. Anode, oxidation. Anode means oxidation. It forms Ag plus. Okay, so the atoms of silver anode lose electrons to form Ag plus ions and enter into the solution. So this is the reaction at the anode, reaction at the cathode. Now the anions like Cn minus, these are the anions formed here, Cn minus and hydroxide OH minus, migrate to the anode, but neither of them get discharged. because of their reduction potential is higher, because their reduction potential is higher than silver. So this is that of electroplating with silver. You can also do this electroplating with nickel. So there the electrolyte will be the nickel sulfate. I am not telling you that. Nickel sulfate will dissociate into nickel Ni2 plus SO4 2 minus. Okay, and a cathode may be same reaction. Nickel Ni2 plus 2 electrons becomes Ni, and that at anode will be nickel Ni2 plus 2 electrons. It loses away. Oxidation reduction reactions takes place in the case of all these electrolytes. So this is a very big thing to be done. I have time as my factor. I am just wanted to tell you the main points of the lesson, so I am doing that. Hopefully you are agreeing with my point. I told you this basic point, electroplating, right? Now we come to the second part of the application, that is electro-refining. That I will tell you verbally. I will not draw here. Electro-refining. Electro-refining is another very important process. Electro-refining means two things are coming here. The word electro-refining means two terms, electrolyte and refining. That is, which means a method employed for chemical decomposition, and refining, which means removing of the impurities from the removal of the impurities to make a pure metal. That is electro-refining. Now this electro-refining is a process by which impurities are removed from an impure metal during electrolysis. That is the definition. And now what for this? Electrolysis of copper, nickel, silver, zinc are done by this electro-refining method. And it is very, very important, electro-refining method. See, electro-refining method, the very good example is given in your book on page number 120. Definition I read out to you. The electrolyte, for example, you will read for your board exam, electro-refining of aqueous copper sulfate. So electrolyte is aqueous copper sulfate, electrode is cathode, and anode is pure sheet of copper, and anode is impure block of copper, anode, because from there only the anode mud will be formed. The diagram is given in your book, page number 120. Page number 120, anode is impure copper, cathode is pure copper, and the anode mud is very important, which is being formed there and which will be told to you now. And the dissociation reactions are copper sulfate breaks into Cu2 plus and sulfate SO4 2 minus. Water aqueous hai, so H2O will break into H plus OH minus. Now what reactions at cathode? At cathode, positive terminal what? Cu2 plus 2 electrons forms Cu. Copper ions are discharged at the cathode and neutral copper atoms are formed. The pure copper deposited as a thin sheet of copper is placed at the cathode. Now what reactions at anode? Again minus, Cu minus 2 electron forms neutral atom, cation, Cu2 plus, and then sulfate and hydroxide, and they migrate at anode but are not discharged for their positions. Instead, copper anode itself loses electron to give Cu2 ions in the solution, and hence the anode mud ka size keeps on decreasing because it is getting purified. That is why it is known as electro-refining. And the impure black copper anode gets used up and the impurities settle up. The pure copper metal dissolves out from the copper anode, and the Cu2 ions formed in the solution at the anode are deposited at the cathode as a thin pure sheet. So the impurities present in the impure copper anode settle down as anode mud. What is anode mud? How it is formed, and where is that copper going? Which contains impurities. Now impurities such as iron, zinc are higher in the electrochemical series, ionize faster and dissolve in the electrolytic copper sulfate solution. So the metals which are extracted by electrolysis are highly electropositive metals, right? This is later part of the thing. For now, what did you get in your mind? What is electro-refining? Electro-refining is the process by which metal containing impurities are purified electrolytically to give a pure metal. And the term refining means pure, electro means to make a method with the help of electrolysis, with help of electricity. So for this, the example of copper sulfate was given in your book. It's given in your book. And the last part of the thing here is electrometallurgy, which I told you. The last application of Electrolysis is electrometallurgy. Now what is that electrometallurgy? As I told you, the reactivity series, if you recollect, sodium, potassium, sodium, K, Na, calcium. First three, that electrochemical series which we have drawn, they are done by electrolysis. Their fused salts are taken in molten state because they are the metals in high order in the electrochemical series which I had drawn in the first part of the lesson. Potassium, sodium, calcium. They are the metals with high reactivity series. They are the high ones, so that's why they are taken in the molten state. And for example, sodium chloride, NaCl dissociates into Na plus Cl minus. At cathode, positive reactions, Na plus, one electron forms Na, and at anode, what happens? Cl minus plus minus one electron Cl, and two chlorine comes together to form chlorine. So oxidation reduction there. Like that will be calcium chloride ke liye for calcium extraction, and like that will be for aluminium. Alumina is the thing used there. For alumina is the electrolyte there, fused alumina. Okay, so this three things are there in a table-like form in your book. You go through that. And what about the reducing agents? What role do they play? They play the role in the middle order of the series. And here, when you read extraction of metals, there you will see the word roasting and calcination. The roasting in presence of air, calcination in absence of air. Which metals are extracted by the process of electrometallurgy? Zinc, iron, lead. Zinc, iron, lead. And the reducing agents, what are used here? Carbon monoxide, and hydrogen. Okay, and because their oxides are less stable, so that's why the reducing agents are used, because they reduce their metallic oxide to metal. These processes are rare in the lesson of metal and non-metal, especially in the extraction part, not now. And what about the lower one? As we come down to the series, where silver and mercury was there, Hg and Hg, how are they taken out? They are taken out by thermal decomposition. Okay, and they are heated, and the metal oxide gets transformed to the metal directly. So you should make a summary of electrolysis. I now wind up with my this part of the video, part 2 of the video. So before I wind up, I would like to say we started with acid, bases and salts, then two examples each. Then we started with what is selective discharge of ions, on what factors does it depend upon. Then what is an electrochemical series? Electrochemical series for the metal to form a cation, how it increases as we go down the group, and these cations are deposited at the cathode, and at cathode reduction reaction takes place. What about the anions? The anions are the negatively charged ions. They are formed at the anode, and a comparison for them was sulfate, SO4, sulfate, nitrate, chloride, bromide that I gave. Then we came how these factors show selective discharge. After that I came to lead bromide and copper sulfate, their dissociation reaction with their figures. Last part was application of electrolysis. First one was electroplating. What is electroplating? What factors influence electroplating? Electroplating of silver on a spoon, that. And then came electrorefining. Electrorefining was taken with the example of copper sulfate, anode mud, all that. Last was electrometallurgy. I think I have completed my part, and by this and with the first part and the second part of the lesson of electrolysis is complete, and this is the base for your electrochemistry of standard 11, and I think I could do what I wanted to do. And thank you for watching my video. Please subscribe and like the channel Science Geek. Have a great day.